If Australia's energy infrastructure is secure, why is the strait that underpins the chemistry inside our batteries now mined, blockaded, and contested between two heavily armed adversaries? Iran's IRGC has deployed naval mines in the Strait of Hormuz. The US Navy is clearing them with underwater drones. And as of the other day, President Trump has ordered a blockade of all vessels entering or departing Iranian ports. Before this war, 20% of the world's oil and LNG passed through that gap. That flow has collapsed. The head of the International Energy Agency has called it the largest supply disruption in the history of the global oil market. Here is the question Australian boardrooms aren't asking. The world's response to an oil shock is to accelerate the energy transition. More batteries, more storage, more renewables. But China controls 80% of solar panel manufacturing, more than 60% of EV battery production, and the majority of rare earth processing globally. So the world runs from one Chinese dependency into another. Australia imports roughly 90% of its refined liquid fuel. Wholesale diesel is up more than 60% since March. And the batteries we're deploying to replace that dependency? Assembled from cells where the chemistry, the processing and the pricing is determined by Beijing. China entered this crisis with strategic reserves significantly higher than most OECD countries. Australia holds roughly 28 days. This is not a climate story. This is a capability story. Energy security isn't decided by who has the most solar panels. It's decided by who can still manufacture, repair, and operate when the waterway is mined and the supply chains that feed it are controlled by someone else. Be ready for today, prepared for tomorrow. VAXA Bureau exists for leaders who understand that intelligence isn't a luxury. It's the difference between reacting and deciding. Today, we're examining sovereign energy storage, not as a transition issue, but as a national security issue. To do that, we're joined by Dominic Spooner, the founder and CEO of Volta, a company that builds batteries in Brisbane. Not assembles them, builds them. Sodium-ion chemistry, no cobalt, no lithium. Patented enclosures designed for repair and second life. And a real-world stress test, a 220-watt kilowatt per hour microgrid held through Cyclone Alfred on Moreton Island without interruption. In a week where the Strait of Hormuz is being cleared by underwater drones and the peace talks have failed, his pipeline isn't growing because of good marketing. It's growing because the risk is now visible to everyone. Dominic, welcome to Intelligence Optimised. Before we get into the strategic picture, I want to start where Volta actually started. Most battery companies start with a cell chemistry thesis. Yours started with a packaging problem. Can you walk me through the moment you realised the battery industry had its priorities completely backwards?
Yeah, sure. Thanks, Todd. I would say somewhere around 2019 is when the penny dropped for me that was something important around the packaging of a battery and what role it had to play in how easy it was to put together or turn into an end user product, and ultimately what sort of you know features and benefits that you can actually deliver through packaging without considering cell chemistry. I was of the belief that cell chemistry was moving at a rapid rate, and that the way that we house batteries or put them together was largely just driven by traditional engineering principles. And for the most part, that meant that batteries, once they were put together, were impossible to pull apart. And that created a myriad of issues, both for myself as a design engineer and for installers and the end customer. I really thought that there was something to investigate in how we put batteries together and what sort of engineering principles we could apply to that.
Right. So, Dominic, you also published a piece challenging the batteries industry's Australian-made claims. And given that Australia is now commissioning a record volume of storage, what does that label actually mean, and does it matter strategically?
It does matter strategically, yes. I would say that holistically, we have tried to be as Australian made as we possibly can, and taking, I guess, our own interpretations of that probably to the extremity, to be perfectly honest. What we've learnt across a few years since is that not the logo doesn't necessarily take things to the extremity, and that I don't have any slight against the Australian made campaign in any way, but because it's the one we've got, and they're not a heavily resourced company either in their own right, which is something that came as a surprise to me, or something that I hadn't considered. So they're not heavily resourced, but I think with batteries in particular, it's important to understand where the supply chain comes into it, what we actually do here versus what we do outside of Australia, and what that actually delivers, and whether that's something that, if you take those critical steps out of what we do here, is that really delivering value? And with batteries in particular, we've really noticed that a lot of companies can sort of lean into this Australian made or Australian owned and designed element without actually doing a whole lot here. And whilst we don't make battery cells, and I don't expect we ever will be developing battery cells or cell technology, the things that we do here, which is develop electronic systems that tie in with existing and new battery management systems. We integrate with local battery management system partners. So our BMS is essentially built here, or can be built anywhere for that matter. But then it comes down to how far you go back to the supply chain. So where are the chips made? Australia doesn't make chips. So, do we have some concerns around, ability to get the chips? I know that when we started one of our projects, it was during the sort of midst of COVID, and chip supply was really short. So that really exposed how fast you could develop a piece of technology, cable harnesses, packaging, the intellectual property that we apply to the battery packs, and how we put them together, and how many people we use, and how many people that are inside of our borders touch that to turn it into an end user product, and then ultimately how we sell and support it inside these borders as well. There's the batteries are not a piece of it's not a white good as much as people want it to be a white good. It is a piece of infrastructure. It should be treated accordingly. So the things that we do inside our borders are actually really important into how we not just sell the product or make the product or manufacture the product, how we actually support it throughout its lifetime, because it needs to last at least 10 years to return its value of being put into the field. So, you know, not like a fridge or a TV, which is largely just, install and throw away. We want batteries to have, repeat life cycles, and to be delivering, performance metrics as well as circularity and sustainability metrics.
Yeah, so I guess what you're describing to me is it's a design discipline that the industry probably hasn't caught up to, which brings me to the environment those batteries have to operate in. Because the supply chain picture, it's changed significantly, and what changed matters in a way most organisations probably haven't absorbed yet. Which brings me to this question: is that China, they've expanded battery supply chain export controls last October. The cathode precursors, the anode materials, the LFP cathode materials, production equipment, they were all restricted. And then under diplomatic pressure, they hit pause. But that pause expires in November this year, 2026. What does that sequence actually tell us about where Australia sits on the energy security risk spectrum?
To be honest, my opinion is that it means that we sit at a pretty high level of risk. The precursor materials, I mean, we have a large stockpile of lithium, and obviously we have a very strong mining and processing industry, but how that material then gets turned into battery technology, and evolved into a battery cell and turned into a battery pack still has a lot of chinks in the armor, in my opinion. And, we're seeing it now. So we saw it in COVID. We saw chip shortages. Battery can't really operate without a battery management system. And if it doesn't have that brain of the battery, well, then, there's safety and performance risks at hand as well. So, our capacity to acquire the battery smarts is still very much at risk. So it's not just the actual battery and chemistry supply chains that I believe sort of exposes Australia, but it's a pretty common thread, to be perfectly honest. So we've seen this across a number of different industries where, during COVID, I think it brought us a lot of awareness around what supply chains mean and the complexities that are involved and what sort of issues we could see if, some of those supply chains are cut off or interrupted or affected. But I don't think we've done a huge amount about it, to be honest. I think, the awareness is there, but we're seeing it again now, with, certain parts of the world at war and certain supply chains affected again, that we're seeing those price increases. We're seeing the panic buying. We're seeing a lot of, you know, concern around our ability to get these things that we thought that we could get whenever we needed them. And it would appear that those risks are still there, and batteries are no different. That we could be cut off. We don't make battery cells in Australia, and like I said, Volta's not necessarily, not at all, the leader in the cell chemistry and the manufacturing of those battery cells. But we do need to maintain partnerships, abroad, and that's China, and that's elsewhere as well. So we need to maintain a working relationship to ensure we can actually get this energy security. So I don't think we necessarily have renewable energy security right now, and we need to maintain those partnerships because of that.
So it's probably fair to say that the infrastructure that's meant to give us independence is itself dependent on the supply chains of potential adversaries.
Yeah, I think that's a reasonable explanation. Yeah, I think there is differences, and the most obvious one being is the sun and the sky belongs to everyone. So we can actually get the power source, but how we turn power source, which we're lucky to in Queensland have quite an abundant version of it and a high uptake of it. But how do we then turn that into the power that turns the lights on, keeps the internet running, powers all of the artificial intelligence tools that people are adopting at a really fast rate, is still sort of up for debate. Even the most Australian and localized companies that are existing in this space at the moment still heavily rely on supply chains from external parties, and local content is largely considered to be an ABN, and that's considered to be acceptable and probably gets sort of shoved through the door as local content and celebrated, maybe perhaps, in my opinion, a little bit more than it should be. And whether it's misleading or not is another question that I'm not going to get too heavily involved in. But I think a lot of people could assume that when you see multiple millions of dollars of projects being claimed as local content, and then you do the digging and find out that they're just ABNs of companies buying product overseas, that's perhaps not quite what they had in mind.
It's definitely a sovereign risk that the government needs to manage better. But Dominic, it leads me to a question. If I'm a chief operating officer or logistics director right now, and I heard that China paused the export controls, and I filed that as a problem solved, thinking it's done and dusted. What assumptions am I making that are wrong?
Any operations manager, if I were to put on an operations manager right now, you would have to have a fairly deep understanding of shipping routes out of China. That's just the simple reality, because battery cells need to come from that area. Lithium iron phosphate in particular, our most widely adopted chemistry or version of the lithium family chemistry, is essentially exclusively out of China. And there is other parts of the world that make that. I'm aware that Japan has some resources as well, and we're working with some parties on that to reduce the total reliance from one part of the world. But it tells me that you need to still have a really in-depth understanding of what it costs, how long it takes, and what sort of risks there are involved with getting those components or critical elements out of other parts of the world to get them here to turn them into products. Like you just said before, the supply chain risk is there, and the one of the main feedstocks, which is the battery cell, is not currently made here, is currently under main policies being thrown to the wolves. That if there is some small manufacturers of battery chemistries and battery products here in Australia, their focus is what they're doing overseas, because the market here is not necessarily providing the best support for that to continue to exist in Australia. We're a small market, and everybody knows that. So every company is obliged to, try to export or expand into other regions quite quickly to, see shareholder value. But the reciprocal value of what we're seeing here is not super encouraging, I have to say.
Yeah, it's tough given I think energy resilience, it's an engineering outcome rather than a policy setting, but you need the right policies to deliver those engineering outcomes too, given our strategic circumstances in Australia. Dominic, that's the policy and supply chain picture that we've touched on briefly. Let's look at what resilience actually looks like when it's tested, not in a lab and not in a procurement document, but in a cyclone. Let's talk about Cyclone Alfred. You had a system deployed on Moreton Island, real infrastructure, a real cyclone, real consequences if it failed. What actually happened?
Yeah, that's a really good story, actually, Todd. Yeah, I'm happy to dig into that one a bit. So, a while ago, so I guess more than a year ago now is when Cyclone Alfred was. We worked with a company called PowerTech and another company called Q-Power Solutions to deploy a microgrid. So this microgrid was on an accommodation facility on Moreton Island, and had an existing relationship with some of the personnel at PowerTech and Q-Power. They were using predominantly aged lead acid batteries that were starting to fail. There was quite a lot of solar deployed, and the system had been sort of built on numerous iterations. So it wasn't just a sort of strip it down and build it all back up again. It was one of the most complex things was for the installation teams to integrate with a lot of what was already there. So older PV systems, inverters, power control. There was a battery room that was full of lead acid batteries, which fortunately, I personally didn't have to move some of those batteries, but I'm sure they got their steps in those days to get those batteries basically onto soft sand and onto a barge and away from the island. But it ended up being quite a job that was done across a couple of installations. But what we didn't know, and what I personally hadn't experienced, actually in my life, was a cyclone in Brisbane. And what became obvious, I guess, about 3 days before the cyclone was that Moreton Island was was going to sort of play quite a big part in wearing the brunt of that first landfall, so to speak. And we watched with bated breath about which direction it was going. And everybody remembers that the cyclone sort of hovered off the coast for quite a while and was a little bit frustrating, but for companies shutting down. But we deployed, I think at the time it was about 160 kilowatt hours, which was a really big upgrade for the facility. It was quite a family owned and operated facility, and maintaining lead acid batteries is just another thing that you need to do, including painting the walls and all the maintenance that goes with a facility like that. And lithium batteries are largely maintenance free, but they needed to work, and they take up a lot less space. And we deployed an IoT sensor that allowed us to do a lot of remote monitoring, which at the time was not necessarily considering a cyclone, but it was mostly just it's difficult to get to Moreton Island quickly in case there's a failure. So we want to have remote diagnostics about what's happening at the system level and inside the batteries as well, which is what most battery companies don't do. They don't usually show or reveal or talk about what's actually happening inside the battery, inside individual battery packs at the single cell level. And we found that to be really useful because a couple of days out from the cyclone, we were able to get in there and make sure everything was operating. And then the cyclone hit. Fortunately for us and for the facility, nothing actually eventuated in too much of a damaging manner, and the batteries came through with flying colours for that entire duration. And subsequently, they decided to upgrade the system further. And I believe we'll continue to go further up through further upgrades, not at the battery level, but at the system level, to make it even more reliable over the next 6 months. So really good showcase, really big test, and a really good sort of pass mark for Volta for that one.
Well, that's a great milestone. Well done, mate. Tell me, on a personal note, what did it feel like monitoring the system during the storm?
Look, to be honest, nerve-wracking to start with. There's anxiety that comes with a storm like that. That you're thinking about your own family, you're thinking about your own home as well. But then you're thinking, I've got an obligation to make sure that our customers and systems are performing, because like I said, energy in our eyes is infrastructure. It's not a white good. It's not an appliance. It's, if the lights don't turn on, then we're on the hook for that. And with a system like this, where if the lights don't work, or if something doesn't work, well then that's going to lead to lost revenue, particularly at an accommodation facility. And whilst there was no one there, that they had evacuated the facility, We didn't want to hear stories about things failing or breaking or flying off or, being damaged. So, to be perfectly honest, I was nervous. It was a big litmus test. But, I was really trusting in our team. We've got, a couple of great engineers, a young guy named Jerome, who monitored that quite intently across that period of time, and another engineer who has since moved on from Volta to bigger and better things, Aaron. These guys were around the clock, and they took a lot of pride and accountability in how the system went.
That's fantastic. That's one natural event. Let's talk about another one that happened not too long ago, which was the heat wave we experienced in January this year. So 6 weeks ago, not that long ago, we had our worst heat wave, Australia, our worst heat wave in 6 years. The NEM battery fleet was tested under sustained demand. Most systems, 2 to 3 hours of support. Cyclone Alfred, that's one event that happens, over a couple of hours, but a heat wave, it lasted for 3 days. What's the design difference between a system that handles both?
Yeah, really good question. I think, Queensland's no stranger to heat, or Australia in general is no stranger to heat waves, and systems need to be factoring in Australian conditions. So, heat, extreme storms, obviously we just went through, humidity is just a really big factor that needs to be considered because, once moisture has a way to get in through metal enclosures, even when they're enclosed. So, you can sort of look at those conditions and say, well, that's just really difficult on electronics. Heat waves typically mean that people will use a bit more power than what they told you. And, it's a pretty typical sort of scenario that when you're talking to a customer, particularly an off-grid customer, they usually speak about what's in as like a currency, that they'll say that you might talk about an air conditioner or a connection device like a Starlink or something like that. And the response from the customer might be something along the lines of can't afford the watts. So it's not a financial decision. It's how much can the system handle. Yeah. So I think what people see as far as system requirements is they do a bit of a balance sheet on what a battery or a energy storage system or solar system needs to be able to produce on a daily basis. And that's typically where a budget is first considered about, what is a day in the life? And that usually goes from residential through to commercial. But then if there is a heat wave, then you need to factor in the extremities and what sort of, buffer you want to include for an event like that, and say, do I accept if we are on grid that we are also going to be dipping into the grid, which I'm sure a lot of these home batteries have reduced a lot of the peak loads on the grid and have helped those heat wave events quite immensely. But what essentially is their budget, their financial budget, to say, well, how many days do I then want to cover? So if a heat wave can cause a blackout, which I guess people our age have probably been a bit more accustomed to it during the 90s and early 2000s, that you might sort of see a bunch of people come home, turn on their air conditioners, say middle of January, and then, hey presto, you've got yourself a blackout and you're waiting for several hours for that power to come back on. And once you start trying to, get kids to bed and start going to bed yourself, you're sweating your way through January. And that's where the frustration really sets in. So, at 9 o'clock at night when you're still sweating away, trying to get to bed, that's when the sort of peaks, or, that's when things really start to get into people's minds about what they value and how much they'd be willing to pay, or how much that budget they need to allocate to, eradicate that potential situation. Queensland is going to get hotter and the world is going to get hotter. So it's a situation that we need to deal with, but I'm certainly curious to see over the next sort of 6 months to see what sort of effect all of these home batteries have had on the grid and what sort of, reliance we now have as a result of that.
So Dominic, that's the home front. That's the residential front. What about critical industry and critical facilities? So if Australia loses access to not only allied logistics support in a major conflict, the Indo-Pacific goes hot, or our partners are committed elsewhere, how long does the average Australian military base, hospital, critical logistics node actually last on what is currently installed? If this conversation helps, give the show a quick rating on Spotify, Apple, or your platform of choice. It really does move the needle. Vaxa Bureau's open source and human intelligence portal tracks national security moves across the Indo-Pacific. Subscribers get real-time signals tied to their strategy. Check the show notes for more details.